Hello everyone, today I am hereby to give a presentation on range for propeller driven aeroplane. In this presentation, I will derive the range expression for the propeller driven aeroplanes. Now I will give a small introduction on myself. My name is G. Simon Reddy, having a PIN number of 21955A2109, and this presentation belongs to your course Flight Mechanics. Next, abstract of my presentation. In this presentation, we were going to derive range equation for propeller driven airplane, and we will discuss some terms which are related to this presentation, and the terms of SFC, in which specific fuel consumption, and next TSFC, which thrust specific fuel consumption, in which the propeller driven aeroplanes will be come across the term SFC. For the jet propelled engines, we will come across the term thrust specific fuel consumption. And next introduction. Range is defined as the total distance measured with respect to ground traveled by the aeroplane on a full tank of fuel. Specific fuel consumption is defined as the weight of the fuel consumed by the reciprocating engines per unit power per unit time. Now next we will discuss about the fuel consumption definition. For propeller powered specific fuel consumption, in which it also known as SFC. The definition of SFC is it is weight of fuel consumed per unit power per unit time. Next, jet powered. For jet powered engines, we will come across the term called thrust specific fuel consumption, which is also known as TSFC. By definition, as you know, that weight of fuel consumed per unit thrust per unit time. And next, now let us get into the topic of deriving the range equation. First, let us discuss about what is meant by range and the basic definition of range. Now, as you know, that the range is a total distance which is measured with respect to ground traveled by the aeroplane on a fuel tank of fuel. It is denoted by capital R. Next, to derive the general equation, the range equation, we should come across some terms like WO, in which it means gross weight of an aeroplane including everything. That means full fuel load, payload, crew, and structure, etc. And next, WF, which means weight of fuel. This is an instantaneous value and it changes as fuel is consumed during, which means WF is the weight of the fuel. As you know that if the plane is moving, it consumes the fuel. Therefore, the weight of fuel will vary with the distance. Therefore, WF is said to be an instantaneous value. And next, W1 is defined as the weight of the aeroplane when the fuel tank is empty. Means if the aeroplane's fuel tank is empty, then the weight we get is known as W1. Now, at any instant during the flight, the weight of the aeroplane is W is equal to W1 plus WF. Since WF is decreasing during the flight, W is also decreasing. Indeed, the time rate of change of weight is next. dW by dt is equal to dWf by dt is equal to dF, because in the above equation we can come across the fuel weight is directly proportional to W. Next, assuming the stationary atmosphere, the aeroplane velocity v infinity is equal to ds by dt, As you know that the velocity means nothing but change in distance by time. Next, then we get dt is equal to minus change in rate of fuel by ct by t. Therefore, ds is equal to v into ct by t into dwf. And next, substituting the above equation, we get dwf is equal to dw. Next, ds is equal to minus v infinite by ctt into dw, which is equal to minus v by ct into w by t into dw by w. For study level flight conditions, we get lift is equal to weight and the thrust is equal to drag, which means L is equal to W and T is equal to 3. Then ds is equal to minus V by Ct into L by D into dw by L. Next, by solving the above equation, we can able to get general range equation. Next, the equation is R is equal to integral of W1 by WO into V infinite by Ct into L by D into dw by W. Next, if we assume flight at constant V, Ct and L by D, then we get R is equal to V infinite Ct into L by D integrate of W0 to by W1 into dw by W. By solving this equation, we can able to achieve R is equal to V infinite by Ct into L by D into Ln of W0 by W1. Next, range for propeller driven aeroplanes. R is equal to V infinite Ct into L by D Ln of Wo by Wn, which is equal to efficiency NPR by Cv infinite into V infinite into L by D into Ln of W0 by W1. By solving the equation, we can achieve R is equal to NPR by C into L by D into Ln of W0 by W1. Next, propeller driven range formula. R is equal to N efficiency of SFC into CL by CD Ln of W initial by W final. By this sum, where R is defined as a range and N is the efficiency and SFC is the specific fuel consumption for the propeller. If we consider the jet, then we will get TSFC, which means thrust specific fuel consumption. Next, CL is nothing but the coefficient of and D is nothing but the drag coefficient of drag, and in place of CL by CD we can able to substitute L by D, because by the from the previous classes we can able to understand that CL by CD can be written as L by D. Therefore, in the previous slide we are written that L by D is equal to CL by CD, where the W initial is a work done by initial, work done by final. To maximize. Next, to maximize range, we can able to maximize the range by using the largest propeller efficiency, because range is directly proportional to propulsion efficiency. Next, lowest possible specific fuel consumption. Next, highest ratio of W initial to W final, which is obtained with the largest fuel weight. Fly at maximum L by D. Next, conclusion. Range is defined as a total distance which is traveled, which is measured with respect to ground and traveled by the plane on a full tank of fuel. Next, range for propeller driven aeroplanes. R is equal to propeller efficiency into SFC CL by CD into Ln of W initial by W final. By this formula we can able to understand the range is directly proportional to the propeller efficiency. If the propeller efficiency of an propeller driven engine is increased, then we can able to then it is directly and it is indirectly we can able to increase the range to get the maximum range. We can able to, if we reduce the specific fuel consumption, then we can able to get the maximum range. And as you know that if we have the large CL by CD ratio, then we can able to achieve largest range. That's it. Thank you.